All right, this is, I guess I could write it up here, chapter 3, question number 25 in your textbook. It's the one with the 3 cabinet makers. So that's my CM1, CM2, CM3, or my 3 cabinet makers. And they're making oak, cherry cabinets. And this is the number of hours cabinet maker 1 has, 50. You can see this table in your book. Cabinet maker 2, 42. And so as you can see, I made my oak and cherry my columns and my cabinet makers my row. These are the hours that are available, and then this is the cost per hour. So what I want to do is I want to separate each one of these into the percentage of oak cabinets assigned to cabinet maker 1, percentage of oak cabinets assigned to cabinet maker 2, and so on. So I use just O for oak, O1, O2, O3, and then for the cherry I use C1, C2, C3. So what I'm trying to minimize is the total cost. Now where these numbers are coming from, and you can see I used Excel to compute them, is I take, for cabinet maker 1, the oak hours to complete times the cost. That gave me the 1800. For cabinet maker 2, the oak times its cost. Cabinet maker 3, the oak times its cost, so 30 times 55. And then the same thing for the cherry. Cherry for cabinet maker 1 times cost. Cherry cabinet maker 2, 48 times 42. And finally cabinet maker 3. So this gives me all of these values that I'm trying to minimize. You can see that they match 1800, 1764, and so on. So I want to use Excel Solver to do this for me. So I have to make a formula for my total, which I'm just really doing this right here, my line, my minimized total cost. So my decision variables, you can see I have 6. So this is where Excel Solver is going to put them in for me. So I simply did an O1, O2. I just made these blanks. I just highlighted them because I know that's where my answers are going to be. So to write the formula for my objective function, as you can see here, what I'm doing, I'm taking the 1800, that's in cell B8, times whatever my decision variable for O1 is. And you can kind of read this straight across, plus 1764 times O2, so that's my B9, 1764 times C15, and then plus my 1650 times O3, and then the same thing for the cherry, 2160 times C1, 2016 times C2, and 1925 times C3. So all I did was I created this formula here to minimize the total, so once I get my decision variables, it will give me that value. All right, the other thing I have to do is set up my constraints, and I did it over here in this box on the right first, that cabinet maker 1 only has 50 hours for oak, 60 for cherry, and then a total of 40 hours. Cabinet maker 2 is matched up with oak 2, 42 for oak, 48 for cherry, and then 30 is all the hours. And then of course then the last one, cabinet maker 3, 30, and 35. And then we have to make sure that these are going to be a percentage, so they all have to add to 100%, that I'm going to make oak plus oak 1 plus oak 2 plus oak 3 equals 1. Cherry 1 plus cherry 2 plus cherry 3 equals 1. And then of course all of these have to be positive values. So on my constraints over here, once again, I just follow along these guidelines. I take my 50 times O1 plus 60 times C1. And I'm just clicking on these empty cells because, again, once I get my decision variables, it'll fill these in for me. So the same for each one of these. Then 42 times O2, 48 times C2, which you can just follow that line. And then also I should mention this is my hours available. this column right here, and then do the same thing for cabinet maker 3, 30 times O3 plus 35 times C3, and then all I'm doing is adding O1 plus O2 plus O3, and then C1 plus C2 plus C3, and these are these ones. These are less than or equal, and these are equal. So now I'm ready to use my Excel solver. So I go to my data, I go to solver, and I've already done this, so I'll get this stuff deleted. Deleted out of here so you can kind of see me do it again. Alright, so set my objective. I click on this so I can just click on the cell. I click on this to the right to bring my box back. This is a minimum. I'm minimizing cost. The variables, my decision variables, are in these cells, so I click and highlight them, cells B15 through G15. Subject to the constraints. Now I have to do the less than or equals by themselves, and then I'll come back and do the equal. So what I want to do here is I want to add, I click on the less than or equal for the left side, make sure that's less than or equal, and then the right side, my 3 constraints, and that's okay, I add those. I want to add the other, so I do my equals. I can do both of these together, and then my constraints are 1, but I have to be careful and be sure I select that to equal. So this is my O1 plus O2 plus O3 equals 1, and then my C1 plus C2 plus C3 equals 1. I click OK. I make sure that I have Simplex LP, and then I click Solve. Now what Solve is going to give you is actually the answer to part B, where it gives you, you can see it's filled in these decision variables and it's giving you your total. But we want to continue and use the sensitivity report, so I'm going to click on sensitivity and I'm going to click OK, and what happens, it adds a tab here at the bottom. Now when I click on this sensitivity report, what this shows me is, of course, cabinet maker 1, I can see for part C, has 26 slack hours. Okay, so I'm looking at this cell right here that gives me my slack hours. I can also look at, so for part D, I can look at the dual value here, which they call it shadow price in Excel. These are the dual values, and I can see that this negative 1.75, in other words, each additional hour for cabinet maker 2 will reduce the total cost by $1.75 per hour. And so this gives me this extra report, and of course I can go back to my sheet 1, and this gives me my values for my total cost that I minimize, and then my proportion. So remember, these are proportional values of each one for Oak 1, Oak 2, for each cabinet maker.